Hello guys, in this video I would like to explain about how to solve the Thevinen voltage theorem based examples having independent voltage sources. So what is the idea behind Thevinen voltage sources derivations, and how and where they are implemented in the linear circuits as well as in complex circuits. So in order to solve the Thevinen equivalent circuit, we have to find out two equivalent components, one as voltage and one as equivalent resistance. In our domestic applications or in commercial applications where we have connected multiple loads, and in future we will have to extend the load, we calculate the equivalent resistance of already installed load as well as the equivalent voltage source, so that we will shorten the calculations in order where we will apply the multiple loads in near future. So the equivalent voltage source and equivalent resistance will be calculated at the output terminals. So Thevinen resistance is basically the open circuit resistance from load end towards source end. The Thevinen equivalent resistance is basically by removing the load, all other resistors will be Thevinen equivalent resistor, and the open circuit voltage here will be equal to Thevinen voltage V Thevinen. How to solve these two things? These are very simple. Here we will proceed about solving these two things. How we will solve the Thevinen equivalent resistor? At first step, Thevinen equivalent resistor is solved by turning off the independent sources. Either they will be current sources or they will be voltage sources, independent sources. So in this example we have one source. At this point multiple students get confused that either I have to open this or I have to shorten this. As you know that we have to make them zero. We have to make them zero. How we can make the voltage source to be zero? If I short the voltage source at these 2 points, the potential difference is zero, so voltage will be equal to zero. Voltage will be equal to zero. So by shortening the voltage sources, we will make them voltage sources to be zero. And for current sources, if I will have current source, how will I make this source to be zero? I will open that circuit. Okay, if I will have current source instead of voltage source, what will I do? In open circuit, the no current flows, it means current is equal to zero. That's why I will make the current sources to be open circuit and voltage sources to be short circuit in order to calculate the Thevinen equivalent resistance. So proceed here. I will make the voltage source to be short circuit and I will calculate the Thevinen equivalent resistance. At the next point, what is the concept for solving the Thevinen equivalent circuit? It is the look back resistance for solving, but the solving procedure is that we solve it from right towards left. So how to solve this thing? See here, from right towards left, 5 ohm is in parallel with 20 ohm. How? Start with start and end point is connected with end. These two resistors will be in parallel with each other and their equivalent resistors will be in series with the 4 ohm resistor. So that's why our Thevinen resistance will be calculated here. So we will solve these 2 points. R Thevinen will be equal to 5 in parallel with 20. Their equivalent will be in series with that, plus 4. Okay, 5 into 25 multiplied by 20 divided by 5 plus 20. These are solving parallel two circuits. How to solve? Plus 4. It will be equal to 4 plus 4 is equal to 8 ohm. How it is made here? See here, it will be their equivalent resistors and equivalent resistor will be connected between these two terminals. See here, I have connected the equivalent resistor here. That was the parallel combination of 5 and 20. That will be 4. And see here, start of one resistor is connected with the end of the other resistor. So these two are in series. So solve the equivalent resistor. We will get the Thevinen equivalent resistance. Thevinen equivalent resistance to be equal to R Thevinen is equal to 8 ohm. This is my Thevinen equivalent resistance calculation. So how we will solve about the Thevinen voltage source or open voltage source? For Thevinen voltage source is basically our open circuit voltage. Thevenin voltage source will be our open circuit voltage. Open circuit voltage at the load and terminals. This is my open circuit voltage is equal to Thevinin voltage source. This was my 20 ohm, this was my 5 ohm, and this was my 4 ohm, and this was my 60 volts. So we see here no currents flowing from this point. I is equal to 0 because it is open circuit. It means we have to calculate the Thevinin voltage across this resistor, because this resistor is useless for calculating the open circuit voltage, because in open circuit the zero current is flowing from here. It is the part of open circuit, so the all voltage will be dropped here, will be our open circuit voltage. So this is our voltage V open circuit. As you know that this point is excluded now, this point is excluded now, you will get this is open circuit voltage. I can erase that thing. Okay, this is open circuit voltage. Two resistors are in series with voltage source. That will I will apply the voltage division rule. I will apply the voltage division rule. The voltage division rule say that the voltage across any resistor will be that resistor divided by equivalent resistor. Equivalent resistor is sum of these two resistors, 20 plus 5 multiplied by the source voltage, that was by 60 volts. 20 by 25 multiplied by 60. Solve these two circuits. For example, with divided by 5, it is 12, and it is 5, 5, 4, 48 volts. V Thevenin is equal to my 48 volts. So the equivalent circuit we will have the equivalent circuit here. The Thevinin equivalent circuit will be equal to my Thevinin source in series with Thevinin resistor, and here is my load connected in future. This was my R Thevinin 8 ohm. This is my V Thevenin 48 volts, and this is my load. That is the procedure explained for Thevinen theorem by taking a simple example. In next example we will explain about the complex circuits. Thank you.